In the last video, we learned a little bit about aldehydes, and we saw that they had the general structure where you have a carbonyl group bonded to some type of carbon chain, or I guess in the simplest form, this could just be a hydrogen over here. And then they definitely will have at least one hydrogen bonded to the carbon in the carbonyl group. So this was an aldehyde. Now, very closely related to an aldehyde is a type of molecule called a ketone. And let's draw a couple of ketones just to make things clear. And then we'll think about what the difference is between a ketone and an aldehyde. So this right here, CH3, CH3, carbon right over here. This right here is a ketone. And you say, hey, Sal, that looks very similar to an aldehyde. I have a carbonyl group in both. So this right here is a carbonyl group. This right here is a carbonyl group. Let me write this. Carbonyl. We have a carbonyl group in both. We have a carbon chain over here. This could be a general carbon chain. Here we have a methyl group. So how is this different? And I think you'll see it's this part that I haven't highlighted yet. In an aldehyde, there's two ways to think about an aldehyde. You could either say that, look, the carbonyl group is at the end of a carbon chain. So the next thing over is going to be a hydrogen. Or you could say that in an aldehyde, you have at least one hydrogen bonded to the carbonyl carbon. And the way I remember that, so you have a hydrogen there. And in a ketone, you don't. The carbonyl group is embedded in a carbon chain. It is bonded to a carbon on either side. So over here, you have a carbon. And the way that I remember the difference, and this is really just a little bit of a mnemonic just to memorize it, is aldehyde has an H in it. Aldehyde has an H in it. There's an H right over there. And an aldehyde has a hydrogen bonded to this carbon. So now that we at least have a reasonable understanding of what a ketone is, let's name a few just to familiarize ourselves. So this right here is the simplest possible ketone, and it's called acetone, or that's its common name. It is called acetone. And actually, the word ketone comes from the German word for acetone, which was, I think, instead of a C there, they had a K. So it's like acetone. And they said, oh, this is a ketone. So this is a common name. Another kind of traditional or common way of naming acetone, and we'll see, or of naming a ketone, is to name each of these groups. And it's similar to the way that we named ethers, but instead of writing the word ether at the end, we write the word ketone. So here we have a methyl group, and we have another methyl group. So this would be, so we have two methyl groups right over here. So this would be dimethyl ketone. This right here is dimethyl ketone. And then if you wanted the systematic way of naming it, you just look at the longest carbon chain, which is 1, 2, 3 carbons. So it's propa. And instead of calling it propane, we get rid of that E over there, and we would call it propanone. We could call it propanone. That tells us that this right here is a ketone. And you have to know where this double bond, and actually for propanone, you don't have to specify it. Because if you know it's a ketone, you know that it has to have a carbon on either side of the carbonyl group. So you actually don't even have to specify where the carbonyl group is. But if you wanted to, you could say, OK, that's going to be on the 2 carbon. No matter what direction you start counting from, it's going to be on the 2 carbon. But the 2 is kind of optional for propanone. The 2 is optional for propanone. Let's do a couple of other ones. So let's say we had a molecule that looked like this. Let's say we have a molecule that looks like this. So the traditional way of naming it, you'd say, OK, on this end of the ketone, I have 1, 2, 3 carbons. So on that end, I have 3 carbons. That is a propyl group. That is a propyl group. And on this other side of the ketone, right over here, I have only 1 carbon. That is a methyl group. That is a methyl group. So then you would just name them, and you name them in order of increasing chain size, or carbon, or I guess molecule size, or group size. So you'd write methyl first, methyl, because it's only 1 carbon. So this is methyl, propyl, methyl, propyl, methyl, propyl, ketone. Methyl, propyl, ketone. This is kind of the traditional or the common way, so often kind of the most used way of naming this molecule. But the systematic way of naming it, you look at the longest carbon chain, and you say, OK, I have 1, 2, 3, 4, 5 carbons. So it's going to be pent. And then you want to start numbering it so that the ketone carbon, or the carbonyl carbon, I should say, has the lowest possible number. So you want to start numbering on the right side. 1, 2, 3, 4, and 5. So this right here, so we said the prefix would be pent. So it's penton. And instead of saying it's pentane, you say it's pentanone. Pentanone. And to specify where the carbonyl group is, you say it's 2. This is 2-pentanone. And you might also see it written like this. You might also see it written as pentan, pentan 2-one. Either one of these right here would be acceptable. Let's do a slightly more complicated example. Let's say we had something that looked like this. So we have something, a molecule that looked like this. Let me stick some chlorines over here. So what would this be? Well, our longest chain, once again, is this cyclohexane. 1, 2, 3, 4, 5, 6 carbons. And I'll just name this systematically right here. And the more complicated things get, the more systematic people will want to name it. So if we have 6 carbons right here, and they're in a chain, so this is cyclohexane. You would put the E there if this was just if this carbonyl group wasn't there, but since it is, we would call this cyclohexanone. So this right here tells us to name it cyclohexanone. And then in a ring like this, this would implicitly be the number 1 carbon. So if this is the number 1 carbon, and we want to number in the direction so that the next groups have the lowest possible number. So we want to make this the 2 carbon. So this is 2,2-dichlorocyclohexanone. So this is 2,2-dichlorocyclohexanone. Now, there's 2 more, and I'll just show these to you because these tend to be referred to by their common names. So I just want to show them to you real fast. One is this molecule right here, where we have a methyl group on this side, CH3, and over here we have a benzene ring. We have a benzene ring over here. Now, that first super simple ketone that we saw, we call this acetone. And so the common name here is actually derived from acetone. Instead of calling it acetone, because it doesn't have just a methyl group here, this is called aceto. And instead of acetone, it's acetophenone. Because we have this phenyl group, that benzene ring right there. Acetophenone, which is a pretty common molecule you'll see, and you'll see it referred to this way. Now, the other one that you might see every now and then, and I just want to expose it to you, is a molecule that looks like this, that has 2 benzene rings on it. So it has 2 benzene rings on it. Looks like that. And this is benzophenone. Benzophenone. These last 2, I just really wanted to expose you to their common names. But in general, I think you have a decent idea at this point of how to name at least the simpler chains, either with the common names, for example, propyl or methyl propyl ketone, or 2-pentanone. And these are kind of the more typical, or maybe the easier naming examples.